From the last tutorial, we are seeing the radiation pattern of a dipole antenna over the ground, and today we'll see the SWR and input input reflection with their resonance frequency with impedance the wire gauge, which is by default set in this software, which indicates some kinds of value with the hashtag which directly entered or directly means the American wire gauge, which is very helps to simplify the simulation. You can see the geometry part. The radius of this designed wire is #3, hashtag of 3, which means that the hashtag of 3 indicates 5.8268 millimeter divided by 2, and this called the radius of this wire, and this called this radius of this wire, which indication hashtag of 3 directly enters this value. So it's it's a simplification of to get a radius without any command by only taking this type of value. So from here you can see the radiation far field pattern and near field simulation radiation pattern, and the SWR with input reflection coefficient according to the range of frequency and your required zone of frequency, and the antenna again with maximum at 76 degree, and when we run the frequencies we get on the range of 280 to 310 at the step size of 0.2. Then and the forward graphs, which theta is 1 theta is 76 degree is the maximum achievement of gain, and the azimuth angle phi is equal to 0. So in the here the total gain is showing here, and the radiation pattern of the frequency back and frequency front is showing here, and the sweeping impedance at the required frequency, and the resonance which is at the required frequency less than the required. When the simulation runs at 300 megahertz, the resonance frequency is at 291 megahertz, where the impedance is where the reactance is 0. So from here we can see the resonance frequency and try hardly to remain the same frequency, same reactance at the specific goal of 300 megahertz, and by optimizing this system we can try to match this resonance frequency and optimistic frequency at the same range of 300 megahertz. So according to them we are taking the value with their accordance. So for the very beginning we are trying to put the value according to them. So using this parameter of dipole over ground and with a radius tag, and run this simulation with other. So at first we have to open this file and open this main window, and then press on this edit NEC input file by confirming the tick on NEC edit or new, or tapping the shortcut key of F4, and by tap this icon we have to enter the new model, and at first you have to put new file and then go to the symbol and put the value of length and height. So put the value of length. We are taking the length is the symbol of L equal to 0.4 0 point. So we are taking the same value of this simulation, so we are taking the value of this length, which is 0.465. We are taking this step, this length 0.465. You can take it as your own, there is no problem to take the length of your requirement. You can take any of this pattern. So we are taking 0.465 as a length indication, and we can take the height of A is equal to 1 meter. So when we like to write a comment, then we have to write it's an ACI height, and the L division length, which is L, and their comment is for L and J. It's not mandatory, but you can put it on, and in the further calculation which takes the value by the indication of this L or H. So at first you have the tag number of 1 and the segmentation. You can see this, and the segmentation is 1, 9. The axis of x1, value of x1 is 0, and the y1 length is L divided by 2, and the z1 is 1, which means the z1 means 1, which is the height of H. If you can take the value of write down H, which already indicates its height, so you can put it as x2 is x2, you can give the value of 0, and the y2 you can give the value of L divided by 2, and the z2 is, you can put the same value of height, which means the positive direction, the height is increasing. You can put the radius of #3 #3. It means they will take the radius according to their gauge section. You can find the gauge section by tapping the length unit, radius unit, inch SWG. You can in meter theta phi. You can find the predefined symbols, which means how the gauge can be saved in a notepad editor window, and how the value. I take the #3, which indicates this type of default content, the symbol meaning, which also already take the it's something wrong. I need to restart this software, restart this column again on the next working session. So at the load section, I have to take the voltage source, and which I can feed at the center of the source. As I have the wire number of wire is 1, so I have the tag number 1 and the segmentation of this wire, where the voltage will feed. So when we take the geometry part segmentation at 9, the voltage source segmentation must be in the middle side of the segment. So the total segmentation of the wire is 9, and the half of the segmentation part is 4.5, and 5 is almost near to the segment. So I have taken the 5 of the segmentation to feed the voltage. Optional option is you set the value of 0, and the real part of this voltage is 1, and the imaginary part of this value is 0. When you put the value of the real part is 1, the magnitude and the phase already take the value of 1 and 0. From here you can you have to set the conductor type, or here I can set the value of the conductor, and that tag number is 1, and the first segment, how the field indication is 0 and 0, and the conductor is which conductor means the type of conductor I used copper conductor. So after full fill this, you have to sometimes there is no load section, so this time you have to check this box and put this box, clicked or tapped to show this dialog. If you unclick this, then the box gone, and if you click this, the box is already showing in the below this source segment. When the frequency segment is entered, you have to put the value at your record frequency. Here I give the 300 megahertz, and suppose I have radiate it free space as a dipole antenna at a minimum height of 1 meter. So when I entered when I tap the running window, then the radiation patterns type of output in various field, which is far field pattern at 300 megahertz and full version or vertical or horizontal. If you want to check, then you can put any type of this segments value, and the resolution is 5 dB. And after setting this, you have to generate. With the generate button, you can see the radiation pattern in the antenna design, which is in the level of in parallel to y-axis and is totally over the ground in 1 meter in the direction of z-axis. You can see this pattern, and here you can see the vertical plane or the horizontal plane by tapping the button or the shortcut key of space bar. You can tap the space bar, then the horizontal plane showing, and again tap the space bar to back in vertical plane. You can press the upward and downward button in horizontal plane to see the radiation pattern of this design parameter. Here the format of this variation of graph, you can see the radiation pattern and where the pattern radiates and the pattern in maximum and minimum point of this value. You can see when you take the value of frequency of 300 megahertz, the wavelength is already calculated, where you can manually calculate it by c is equal to f lambda, where c is equal to 3 into 10 to the power 8 and meter per second, and the frequency is 300 megahertz. So if you calculate this at the manually, you can see the same result in meter. So here you can see the voltage, which is the phase real part is 156 and the imaginary part is 0, where you already take in the geometry section, source and load section, source portion. Impedance, you can see where the impedance is at your 300 megahertz frequency, and the SW as 50 ohm is 5.74, and the efficiency radiation efficiency and the radial power is 99.9%. So after checking this in radiation pattern and geometry, you can see this at 180 degree the maximum gain happens. You can tap the graph, and you can rotate the cursor at any directional point to see the radiation, which where the radiation is maximum. You can see there is no value change in this circle of the radiation is radiation is 2 decibel. You can see the radiation at 180 degree is the maximum which is theta at 2 decibel. So from this you can see the radiation pattern, and you can, if you want to check the frequency sweep near field pattern, you can set the near field pattern and tap to generate, where the radiation pattern radiates in this type of format, where the violet portion totally indicates the maximum radiation part of this design parameter, and the yellow is the medium range, and the green is the here the maximum radiation happens, and the blue pattern of this area is means that there is no radiation pattern of this antenna with extends in this section. So after seeing this near field pattern, we are ready to get a frequency pattern at this direction of at this range of frequency, and when we are taking the 250 to 350 as a step size of 1, which means the step size 251, 252, 253 happens this type of pattern. So we are in this pattern we are taking the maximum theta, which is 180 degree, the maximum gain angle, and after tapping this frequency sweep at 180 to 5 is equal to 0, the generate button, pressing the generate button, we are getting this type of radiation, this type of cell pattern, and this type of radiation pattern, and we can get the impedance value or SWR, which is at 300 megahertz. At 300 megahertz, you can see the SWR is 5.74 388. You can see that here there is the value. Here is the value of 5.74 at 50 ohm. 50 ohm is a standard to design antenna, which the impedance of the real part of the impedance gets 50 ohm as a standard in between of 0 to 100 ohm resistance. So when you get this value, when you get this value at 300 megahertz, you can take it from here. You can see the reflection coefficient is minus 3.0555 at 300 megahertz, and even since the value in that by tapping, since the value, or see the gain or frequency ratio, gain ratio, which by tapping the second option, or by pressing the G shortcut key, or I the impedance phase curve. So by pressing the maximum gain parameter, you can when you put the cursor on the 300 megahertz, you can see the maximum gain at 300 megahertz is 2. If you shift the cursor at the right side, you can see this gain is increasing tremendously. So by tremendously, and at the final stage, you can shift the impedance or phase button, and you can see there is radiation pattern which indicates at 300 megahertz the maximum value at 300 megahertz, the maximum value of resistance part, which is 46.8428, and the reactance part, which is minus 95.745. Minus 95.745. You can see there is an impedance part of this section. Here the real part of the resistance value, which is 46.8, and you can see this head is also the same, the 46.8 at 300 megahertz, and the reactance part, which is minus 95.742, and here is the 95.7, which is really the same at the frequency. Here you can see the impedance part, where the impedance Z means the magnitude of this impedance, total impedance, and here the violet line which indicates the phase angle of this total impedance. So here total impedance. So from here you can see the gain parameter and the SWR at this radial frequency. So we need the impedance. So when we take the impedance, there is the value of this radiation pattern, and you can see there is the value is increasing tremendously at the right side of the parameter. You can see the optimum frequency of our desired frequency is 300 megahertz, but here is the resonance frequency. The resonance frequency, we get the resonance frequency where the value of reactance is equal to 0. The is 0. The radiation, the impedance, whatever the resistance, value of resistance is at 0 reactance, it does not mean so if you see the value where the radiation reactance is 0, you can see there is a close point of minus 0.8372, where the impedance is almost 0, reactance is almost 0, and the resistance of this radiation pattern is 71.4071. In some terms, you have to design an antenna where the antenna radiates at 300 and the antenna helps to the antenna condition seems to radiate in this parameter where f naught and fr, which f naught equal to fr, which means the optimum frequency is equal to the resonance frequency. You can see that the value of reactance is 0 and the resistance is 71.4071, and here the frequency is 348 megahertz, which is very much greater than to the optimum frequency of 300 megahertz. So we have to match this frequency at 300 megahertz to see the radiation pattern of the impedance. For this we have to follow some steps. At first you have to close the editor window, and after before closing this editor window, you have to save this file as your favorite model name. So I can save this antenna at the name of Tutorial-3 and over the ground Optimum and resonance frequency. After saving that, I am closing this tab, and after closing this tab, I am go to the calculator window and start optimizer by pressing the F12 button. You can see there is an function option of coming in this parameter of this running value at 300 megahertz. You can change this value, but from here I am already designed a parameter at 300 megahertz. This frequency means in which frequency you want to match the resonance frequency and the optimum frequency. By default there is the value of x in is equal to 100, and you have no need to change any type of value. In the previous run, you have to just select the value of length, which when you tap the value of length, you can see the selection where the pattern is already taken, and you have to take the value of height, where the value of height already selected. After selecting them, you have to press the button of start, and you have to wait for a while after to run this simulation. When the simulation runs and the process remains continuously to match this resonance frequency and this optimum frequency, and changing the impedance or SWR at this resonance frequency time, you have to wait for a while to run this simulation to match this frequency. They have already automatically run in this parameter, and when the run is stopped, you have to update the NSC file, and then you have to run in the geometric window in frequency sweep and radiation pattern. Then you can see the radiation of the frequency, optimum frequency, and the record frequency is matched, resonance frequency is matched in this parameter. So we are waiting for a while to stop this simulation. This simulation is running tremendously. There is no right to stop. So we have radiation pattern in this function. So if we tap the step or press the stop button and cross update the NEC file as saving this file name as facility yes, and clicking the geometric tab and simulate this simulation in frequency sweep of this range, and by pressing the resolution 5 degree then generate we can see the impedance where the impedance is matched. You can see there is the portion of this value where the reactance is equal to 0, almost equal to 0, and the resistance of this value is 71.6523, and you can see that there is the change of value of impedance and phase angle here. So there so you have to you can see already after optimizing this simulate and upload this NEC file, you can match this resonance frequency to optimum frequency in this parameter, and the value of the frequency is matched, and the value of the resistance and the value of the impedance is already shifted to the other value. So the frequency shifting operation is already done. It's a work to match this frequency and work all over the simulation to see what happened in the resonance frequency and the optimum frequency is same. So from here, if we want to see where the antenna radiates at over the ground level, we have to put in the vertical zone and in the vertical zone. So we have to work in this side. We have to press the calculate option, or pressing the F2 we can already start the F12. We can select the optimizer and function, which is the sweep portion, and there is the vertical option, tap on the vertical and tap on the height, and at the maximum is the range. You can see at the radiation pattern you have to what the maximum value you want to give. You can see there is the value where there is already given in this parameter sweep. It is that you have say task is given in this that the simulate the input impedance of the thick dipole of frequency 300 MHz when having the height over the ground between 0.5 and 1.5 meter in 20 steps at 300 MHz frequency. So here we have to see the minimum is 0.5 and the maximum is 1.5 according to our given task, and we have the maximum gain at 180 degree and the azimuth angle or phase equal to 0. We have taken the resolution is 1 and the number of steps is 20, which is already taken in this simulation, or 20 which is given in this task for simulation. You can see that the 20 steps is called, and 0.5 to 1.5 meter is the height distance, total height distance. So when we pressing this at this type of running simulation, we have to start the option and wait for the 20 steps, have to off end of sweep and pressing the wake I can update, and after this you have to update NEC file and yes, and then you have to cross and take the geometry window and run in frequency sweep at the same pattern you previously said. Then you have to see the impedance pattern of this curve is that there is a reason happens due to the old and latest edition of this file. So maybe there is a problem to show the radiation pattern. If we see after pressing this frequency switch, we have the radiation pattern in this field. When we press the button sweep and the height is 0.5 to 1.5, and this 20 number of steps and start. I have the change of radiation. You can see the radiation in this frequency. You can see the value and the radiation is already stepped up in the direction of 0.1 to 1.5, 0.5 to 1.5 meter. And if you press the F5 shortcut button, you can see the gain and the impedance, gain level according to the height, for 1 meter and 1.1 meter, 1.05 meter. You can see the radiation pattern according to their gain. The value is already almost the same at the same point. Maybe at the end you can see the height parameter is already shown in this curve here. Maybe there is a double increment of file makes the pattern different. You can see the 3D radiation pattern here, and to get the color radiation you have to set the height pattern to multicolor, and you can see sorry, there is no radiation pattern here, but the radiation must be in this type of shape. So you have to if you want to see the Smith chart portion of this value, you can see there is the value where the radiation and the seems happen. You can see there is the frequency of 0.5 megahertz. So it means after clicking the double update of this NEC file, the radiation patterns shifted to its latest update, and when the frequency steps down to the 0.5 megahertz. When you radiate this or when you work on this file to update at the first time, you have to see there is the frequency which must be in same of 300 megahertz. So it's not a matter of fact you can pressing the cursor or shifting the cursor at any point, the direction is showing, and the value of the radius of this one is already showing 0.178, and the impedance is showing here, and the parallel impedance showing here. You can see the scale of SWR and decibel and voltage ratio. So take your value at your desired system or desired number of punctuations in this design parameter. And next we will see the design of helix antenna of this tutorial 1, which may be the last tutorial in this slide. And after this we are taking the number of values of this taking the number of values of this parameter, and we can find in this next slide of the different types of value of resistance, impedance, reactance, and resonance frequency. When the resonance frequency is same to the optimum frequency, So we are meet at the next slide. Till then you have to wait and see the same property and exercise. You have your own. Take your time. Thank you.